Maria,
What do you want?
can you teach me about triangles?
Fine. Just give me a notebook and a Sharpie or something.
Okay. Here.
Well, first of all triangles add up to 180 degrees.
Really?
Yeah, really. First triangle we're going to talk about is called a scalene triangle. No sides are equal, and that makes no equal angles at all. This is an isosceles triangle. Two sides are equal, and two angles are equal. Bet you didn't know that.
No, I did not.
Now this is an equilateral triangle. All sides are equal, indicated by these lines here, and all angles are equal. And that makes all the angles 60 degrees.
Oh.
Because, 60 plus 60 plus 60 equals 180.
Really?
And that's how many...
You could do that without a calculator?
Yeah, okay. Now we're going to talk about the Pythagoras theorem. This helps so you can see with a right angle triangle to determine and find the sides. As Mr. Forseth stated in some of his notes, to find the sides of a triangle, it must be a right angle triangle. So the Pythagoras theorem is a squared plus b squared equals c squared. For example, we have this little triangle here that this measurement is 5 and this measurement is 9. So this is A, this is B, and this is C, what we're trying to find out. C always must be this angle, because this is the hypotenuse, and the hypotenuse is always C across the right angle.
C equals hypotenuse.
Yeah. Okay, so since A is 5, and B is 9, 5 squared plus 9 squared equals C squared. 5 squared equals 25, and 9 squared equals 81, so 25 plus 81 equals C squared. Since there's a square, we have to square root it to get rid of it. So we end up square rooting the sum of these two numbers, which is 106, and we get 10.3 approximately. So C equals 10.3, and we use that finding the Pythagoras theorem. Now we're going to talk about congruency. Congruency is when two triangles are equal in every way. There are 3 tests you can use. First is the side-side test, SSS. Then second is the side-angle-side test, SAS. And the third test is angle-side-angle, ASA. With the side-side test, this makes each side equal to each other. So triangle ABC is exactly equal to CDA. We can tell by these lines here that indicate that this side is equal to this side is equal to this side, and these sides share the same side, so that means they're the same. Making both triangles identical.
I've never seen that before.
Really? Okay, now we are going to use side, angle, side. In this diagram, we have this little line here, and a dot, and new 2 lines. It's identical to the other triangle beside it. That makes this a side, angle, side. Triangle PQR is equal to, and this little line here shows that it might be only approximately, to triangle TRS. So this is an SAS triangle. Then ASA, angle, side, angle. It's like a big old Z rule. As you can tell, these 2 lines here are parallel, and they're also equal. This makes this angle and this angle equal, and this angle and this angle equal. So it's angle, side, angle. So triangle ABC is equal to triangle DEC. Now we're going to talk about similar triangles. 2 triangles where one is a blown up version of the other, more or less. This little triangle here is kind of crappy diagram, but whatever. Similar triangles have all equal angles, AAA.
You said a square.
Did I? This is kind of complicated, but if you can see, all these angles are the same, and the angles here are the same. We say 18 and 6, and they relate, so we show 18 over 6. this is 27, and we don't know what this side is, so we make it x. And this one, we know this is 7, but we don't know what this was, so we'll make it y. But all we know. So 27 and x, it has to equal 3, and y, 7 equals 3. 3x over 3, 27 over 3, is equal to 9, and equals y, and that equals 21. We can tell that each of these angles are similar because you just times this by 3, and that's where we got the 3 from in the first place. Because 6 times 3 is 18. What's 27 divided by 3? So we got 9. So that makes these two triangles similar triangles. And that means they're similar. So ABC is similar to XYZ. Oh. I'm really tired. I want to go. Get out of here!
Quadrilaterals and everyday objects with Maria.
A quadrilateral is a four-sided shape. All its angles add up to 360 degrees. The first quadrilateral we're going to talk about is a trapezoid. Just like this sandwich, a trapezoid has two parallel sides. If we look at it in a different perspective, there's a line here and a line here, and it creates two right-angled triangles with a rectangle in the middle. We'll talk about a rectangle later. The next quadrilateral we're going to talk about is the rhombus. If we look closely, if you draw invisible lines inside the rhombus, it creates four right-angled triangles. Each side, this side is parallel to this side, this side is parallel to this side. All sides are equal. The next quadrilateral we're going to talk about is a parallelogram. Both sides are parallel to each other, though only these sides are equal to each other, and this side is equal to this side. As you can tell by these little lines here. 1 and 2. The next quadrilateral we're going to talk about is the rectangle. All sides, this side's parallel to this side, and this side's parallel to this side. They're all right angles. And finally, it's the special quadrilateral, almost like a special rectangle. It's square. All sides are parallel to each other, and just like the rhombus, we can draw imaginary lines and create right angle triangles. In this shape, all sides are equal, and so are all the angles, of course, because they also create 90 degrees. Well, there you go. That's some shapes, some quadrilaterals. And we can see, by the different geometry, that shapes are really in all our everyday life. Quadrilateral shapes. Oh, hey. Chords have been around for a long time. From the keys on your piano to the chords you play on your guitar. But chords and math are totally different things. Let Job for a Cowboy explain the methods of chords in their own obviously clear lyrics.
It's not something to throw. We cannot stand this for the fighting against the unposted threat. Leader now son of shame, with another beginning to flourish. He's let us wandering, shining, just pushing and pushing, our fighting, coming up with mother's love. Glory of love.